So do we have, yeah, good, hi. Hi. So I'll start. You know, one of the conversations that we were having at break time was how we train people, docs in particular. You know, actually, and let me do it. Let me go a different way. One of the books that I would recommend that everybody read is Kahneman's "Think Fast, Think Slow" or "Thinking Fast, Thinking Slow," which gets to many of the biases that Dr. Kim was talking about, and we close the triangle all the time, and if you're in a 15-minute box, you've got to close the window, or you've got to close the triangle, which then leads to the question. I'll go back to the question then. And we need to train clinicians differently. Yes?
Completely agree. Speaking physician to physician, I think we are notoriously prone to, well, we've been labeled divas appropriately in our own systems. We don't tend to bend from traditional hierarchies as easily as some other members of the force. So I'll start with the physician community.
Right.
We're perpetually training for the model of today, when in this particular instance, we desperately need to have clinicians not only involved in AI, ML, algorithm development, we need our learners speaking the vernacular from day one. We need them understanding, we need them listening to Dr. Kim and to others and teaching us what the vernacular for the next 20 to 30 years looks like. And we really need champions at the training and institutional levels to help us get there. I think in the talk this morning, the 30-year lag time between conclusive evidence of surgical infection and an acceptance that we need to be doing something about it systematically has really not changed that much. We were still estimating there's a 17-year lag from conclusive evidence making to universal practice a decade ago. I don't know what the most recent estimate is, but you absolutely looking at a 34-year career span, and yet you still build your training models around the model, or again, around the delivery system of the day. And we keep saying in family medicine, which is going through a big change, it happens about every 15 years, the rules that govern what a residency program must do in its training environment. We say the clinic is the classroom. You can put in whatever curriculum you want, but if you don't set up the clinic where that trainee, again, learns for 3 to 4 years in our field, their craft, you will have an imprinted effect, just as you do on ducks, for 7 to 14 years on their delivery behaviors, their cost behaviors, their quality behaviors. So absolutely.
So Ryan, I don't want to. I really could monopolize this conversation. If people have got questions here, you got a long walk over to the other side. But while you're going there, one of the actually, I don't know if you heard the talk this morning. Dr. Kirk was talking about. He's a surgeon and a system that is his scalpel got closer and closer to something he wasn't supposed to cut. It should shock his hand or something, and that's not exactly where he went, but it was in his ear. What I'd like to hear is, "Oh, I wouldn't cut there, sir." And what I would and you were talking about the human-computer interaction. My understanding, and I have no trivial understanding of how AlphaGo works, is that move 34 or 7 or whatever it was has been described as a non-human move, or a move that a human wouldn't make. And yet it was absolutely the right move because it clearly won. And we've been doing medicine for millennia without knowing what the mechanism of aspirin is, how a diuretic lowers my blood pressure. And how do you, and there's got to be some times when you just say, "Trust me, I know this is right." Or conversely, "I have no clue, you're on your own." And is there a way to get at a balance there?
A great question. Just FYI, so a little delay. I'm listening to your talk in other computer and then responding to another computer. So there might be like a lot.
You're doing
Awesome.
great.
Great. See what you just said. I cannot hear, but once I switch over. Such a great question. So something that I'm currently working on is to achieve that balance. Because the truth is, yes, that move 37 was amazing. It turned the game around for AlphaGo. But chances are that there are other moves that humans could have come up with that's potentially even better than that. It's just one way of solving tasks. And there are many different ways, perhaps better ways that human will come up with to solve the same task. So the goal ultimately is how do we synergize with each other? When you're wrong, I tell you that you're wrong, and I'm wrong, you tell me that I'm wrong. And one first very concrete step to do that, currently that I'm working on, is when model has explanations and it isn't sure about explanation, then it should tell me that like, hey, I think this is right, but I'm not quite sure. So that encourage humans to go with their gut feeling and your experience. That's one of the first steps. But that topic that you just touched on is such a core part of what we care about. A lot of machine learning people, interpretability, and people who do, the people in that audience really, to like how to keep that balance rather than just one overriding the other.
Questions? Go ahead.
Yeah, so I'm still trying to figure out the right way to articulate this, so it'll sound a little not fully baked. But I've always struggled with interpretations and our understanding of pathophysiology and mechanism in medicine. So I was like a pure math major where you start with assumptions and axioms, and they are static. Like throughout the problem solving process, things don't change. So I'm not old. I started medical school 11 years ago, but I mean, there's still so much that I learned 10 years ago that's getting turned on its head. So folks may have heard the amyloid plaque hypothesis for Alzheimer's. The last 20 years of Alzheimer's research may be like totally misguided. EBV and mononucleosis and MS is a discovery within the last year, long-term effects of viral illness. A few years ago, there was a set of studies in the New England Journal about the role of aspirin in primary or secondary prevention in cardiovascular disease. So one of my favorite examples of this, it's jokingly called the oculostenotic reflex. And it describes cardiologists who see calcification in a coronary artery and have the reflex to intervene and to broaden the artery. And that mechanistically, it makes sense to broaden arteries that are blocked. But that even though from a physics standpoint, it makes sense that that would improve flow and improve heart function, there's a lot of cases where that is not actually what needs to be done. And I feel like part of this question is inspired by the fact that your Venn diagram was fixed. It's like something that's known, it either expands or it doesn't, but like it can shrink too. Something that's part of the circle can be like totally removed from the circle. You can punch holes in that circle. So I'm just always curious if we've found some like local minima or local optimization for facts that we have today that like is actually missing like the global optimization with information that we don't yet have. And I think we can point to plenty of examples where humans have found interpretations that are false. I'm sure we're going to come to understand interpretations from computers that turned out to be right, that we thought were like totally wrong up front. And it's just, I guess like for me philosophically, it's just really hard to know what to make of these things because science is so dynamic in medicine and these axioms and assumptions of what's true are not static. So I'm just curious for both of you how you think through this, because I think this is part of what MLHC at its core is like most complex.
I think that's your paralysis box. Keep going.
Don't take the Twitter.
Sorry, Dr. Kim, go.
Yeah, okay, cool. I thought that monitor you're pointing is me, or it's somebody else.
No, you're right there.
Right, I can't hear you, right? Because I'm talking. I'll hear in a bit. So the question, back to the question. I encourage you to think about it this way. It is overwhelming sometimes that, okay, what is truth and what is not truth? Now we have this another complex thing in the mix, the machines, so what are we gonna do with these guys, this complex thing? But think about it this way. It's just like another humans who have great expertise, but still can be wrong at times, educated, trained in a different way, have a different hypothesis, and they're coming up with ideas and hypotheses that some of which are wrong, some of which are right. And that's kind of many smart people like doctors over many centuries. That's how we advance science, and through discussion, through criticizing each other, through experimentation and rigor. And that's kind of how we're going to have to do it with machines too. Just think about it as like beneficial coworker who jumped out of nowhere and in front of you and trying to communicate with you. And that's kind of maybe parallel to the diagram that I showed. Like there's a lot of stuff going on. It's a little overwhelming. It seems complex, but at the end of the day, we try to hold on to our values and try to do our best to test it, iterate, criticize each other, do good science. I think that's the kind of only way forward.
Mark, I'd only add, since I was asked earlier about what's your specialty, and you perpetually in family medicine have to explain what a specialized generalist means, that this is a specialty. This is no longer the general practice of the 1960s. I would say inherent to the training and to survival is avoiding the paralysis box, because it is otherwise, the burnout is real and makes sense to me, because if you can't avoid the paralysis box, if you can't accept fundamental dynamism in the knowledge base across this incredibly broad range of what should be specialties that you have to master and then translate into day-to-day practice across a range of conditions, then you're not going to make it very long in primary care. So I don't really have an answer for your question. I just say that it's one more reason why the approaches that I hear emerging from this conference and everything that Dr. Kim has talked about is a good fit for the natural generalist. This is this dynamism of knowledge, and this flexibility is how we're supposed to be wired when we come through and then out of training. And we should be logical partners in helping to sort out that balance between the perfect, or maybe not perfect, the ideal move that the machine has crafted and the human instinctive move built on something we don't fully understand. So,
Right, there you go.
My name is Ali Karimi. I got one suggestion. I came in from background of the NASA unknowns, and I saw the healthcare 20 years ago is the unknowns too. That's why I joined the healthcares. One of the things I see that, like Dr. Kim said, that the human, we do have around one circle, but we need to move it to a little bit more to other intelligence. One of the issues I do see that right now, most of the information system or care providers, they see their EHR. And when I look at the EHR, it's a lot of black data. To me, it's like when I was at NASA 40 years ago, we were going to the moon or we're going to Mars today, still is black data coming in. And how did NASA resolve that? They went to the edge. For example, one of the proposals I'm putting for the Department of Health Services and NIH is when you go into caregiver from ER, they would have their own edge artificial intelligence combining by the ER doctors. And they put the information and intelligence what the ER needs when they move the patient, outpatients, or inside of this unit, ICU and others. This resolution has to be by each unit, and each area of the healthcare, they are different. You go with different race, they do need different type of health. What my proposal is, the intelligence and the physicians at the area they get together. Don't look at the EHR. I'm sorry, AWS and Google's, you guys know a lot of things, but you don't know how to distract the real information. The distraction comes in from the dirt and the ground, which is each unit. We should work directly with every unit of the care provider, EHR, ER. We work with those physicians, with the scientists or the algorithm. And when you go into ICU, that's a different. That's how we can gather these information. Fine. Then after that, you can send it to EHR, the information. That's, I think, the approach we done in NASA. We used to look at every Mars and Neptune would be the same, but actually it's different. I mean, instead of wasting time, we could go into the nuts and bolts. Sorry, that's my.
So I bet
So-
you and I could have a conversation. We could complain here for till the sun goes down about the EHRs.
I'm on my fourth.
Sorry, I'm on my second. But I couldn't agree with you more. And it's and the, you know, one of the interesting things is, and we've got all our data in Epic. There's 5 million patients within the health system that I'm in. Within anesthesia in the ICU subset, we take care of about a quarter of the patients. We touch them at some point, but we've got 80% of the data, which means the other 75% have data at a much lower granularity, which is the problem I'm delighted you deal with.
We're involved with the Center for Disease Control in a 2-year project trying to get an early understanding of long COVID, and utterly dependent on our prime registry's extraction from EHRs, because that really is the repository of most of the information, you know, around the clinical space. And it's our Stanford partners who are the informaticists. And I spend most of my time on calls with both groups trying to interpret something from someone's electronic health record primary care encounter that doesn't even make sense to me. And that's part of the peril we face, is the heterogeneity you need at the unit level also leads to such garbage in the repository we're dependent on to drive our AI ML solutions future. And I really feel for the informaticists and the analysts who are forced to try to understand the poor translation of what happened in my encounter as captured in the record. And it's also why I'm particularly
Sometimes you have to separate the marketing,
yes.
like the real needs.
Well, right. And where I would go with that is, you know, all the EMRs were designed to replicate the paper chart, which they've done reasonably well, and bill.
To drive billing.
And what we really need is an avatar, like that it would be a representation of the patient. So we're talking about the same thing when we hand the kid off. They're all kids to me, sorry. Hand the patient off from the outpatient environment to the inpatient and then to the ICU. And you're right, to shove the data into the EMR at the end.
And that avatar would start capturing information before the patient left their home, if they came in at all.
Correct.
And through the kiosk, at least in primary care, through the kiosk process, my MA's information will be captured, family members, and not leave it to one interpreter who's overcharged with patient care and undercharged with time to document, and wouldn't allow me to do a lot of cut and paste work that really doesn't document what happened in that specific encounter. So.
Go ahead. Question from the back, please.
Hi, I'm Ben. I'm from London. I'm ICU doctor. Thank you both very much, by the way. Fantastic talks, both. I've realized there's a lot of overlap in medicine and AI, and that kind of part of that is that the boring stuff is maybe, or the less sexy stuff is where you get best ROI or return on investment. Sorry. Do you both have advice on how to make people realize that maybe, for example, the latest cardiology percutaneous device that costs £50,000 or dollars, they're actually doing high quality HbA1c management or blood pressure management might be worth more than that. And it's exactly the same in ML, devoting time to looking and understanding your data more, putting that in at the beginning is actually worth more than trying to chase the latest interpretability. Do you both have advice on how to kind of make people or show people that, get people to maybe take a break from the really sexy stuff?
You're up, Dr. Kim, go.
Thanks. Is that better?
Yes.
There's like 100 beans. I really appreciate that question because that's something that I've been thinking about how to do better, how to make people take an action. So I think 100%, most of the people in machine learning research community is aware of this, that yes, the data and thinking about studying the data is going to be the 88% of, if not more, of getting the better algorithm better in ways that you actually care, right? One concrete suggestion that I've been pitching for, and I think there's some movement on, is that one of the ways to understand data in the computing field is visualization. Now, visualization for someone who in machine learning or computing field is not maybe like immediately approachable area. It's more maybe artistic, maybe it feels like less sciencey, and that sentiment, I think, is preventing us from investing more in visualization so that we can better extract, understand information from this data so that we can save time for humans in reading this data, detecting problems, and studying all the ways that this data itself can go wrong. There's a huge movement in HCI. Actually, VizXI is something, a workshop every year that happens in CHI, Biz conference that collects these practitioners who are looking at the data, interested in making visualization. And I think that community is growing. But partly taking like a 10 step back, I think there's this, and I'm gonna be reaching a maybe risky move. I think there's a little bit of arrogance in machine learning community, to be completely honest with you, that, oh, we do compute, we do algorithms, oh, we have computers, and like everything else is not important. And that perhaps that that sentiment is propagating to like, well, yeah, you have to have clinicians in your paper, but like, oh, it's so much work, and like they're not, like it's gonna take time to communicate with them. And I think that arrogance, to be perfectly honest, is kind of in the middle of it. And people are starting to understand that arrogance is not good and not getting us to where we want it to be. But there's definitely a lot more work that has to be done.
I just had excellent question. You just about turned the conference into a social accountability and equity conversation. And I won't go there, but I will say, so long as the business of America is business and we've built a welfare system that tries to achieve health through healthcare, it's challenging to communicate, again, and overcome certain U.S. health and healthcare cultural norms. And I speak as a family physician with great envy of the sexiness of the ICU setting and the surgical suite, but also with an awareness that, my path was really born of seeing the insufficiencies of pouring dollar after dollar into curative end-of-life therapeutics without focusing upstream. That is another conversation for another day. I'll just add one thing. The reason I put that slide up from the Steve Lin, Krasinski paper is that's one of the visualizations that is compelling, I hope, to, again, an industry-driven approach to design in AI and ML, and it really lays out, all right, there's $100 billion here, $27 billion. So over here in risk prediction and improvement, there's $27 billion in doing a better job of telephone triage. When you put big numbers on it, you start looking at the gaping, not just low value care and waste, but the gaping expenditures that offer potential for artificial intelligence and machine learning to change health and ultimately that quintuple aim. It's really eye-popping how much comes from going far upstream, and not just into the primary care, but the primary healthcare and community setting. What you're doing at the patient level before they ever see any of us or touch the healthcare system offers real power, and you can put numbers to it, and that's probably the best answer I have.
All right, I think it's time to wrap up. I will comment for Dr. Kim. You have flipped the way I think, which is why I come to conferences like this. To think that I should think about a machine that, as Mark said, is just math as a human is really mind-boggling, but I'll give it some more thought. But boy, am I glad I did intensive care, because what you do for a living is much harder than what I do. And if there's students out there who haven't decided what they want to do for a living, if you could get these two people to mentor you and push you in a direction, you're in a field that's wide open and would do a boatload of people a lot of good. So let me just thank you both.